velocity, तो ये होता है displacement upon time interval. Next is average speed, it is distance traveled by time interval. Next is instantaneous velocity, इसको dr देखा जा सकता है जहाँ पे r पोजीशन वेक्टर है, या अगर कोऑर्डिनेट्स हैं तो इट कैन बी रिटन इन फॉर्म ऑफ dx by dt और dy by dt और dz by dt given that motion is on either x axis, y axis or z axis. Then we have another point which is speed, instantaneous speed. So it is magnitude of instantaneous velocity. It can also be written as mod of dr by dt or mod of dx by dt, dy by dt or dz by dt, depending upon that whether motion is taking place in space or along x-axis, y-axis or z-axis respectively. Then we have another point regarding average acceleration. So average acceleration is change in velocity per unit time, which is final velocity minus initial velocity by time interval. Then we have another point related to instantaneous acceleration, it is dv by dt. Then we have momentum is equal to mass into velocity, average momentum as integration p dt t1 to t2 by t2 minus t1, and this is also equal to mass into average velocity, and we assume that mass here is constant. Then we have average force, so it is integration f dt t1 to t2 by t2 minus t1. It can also be written as dp by dt. Then we have another theorem which is called as the work energy theorem, according to which work done by all forces on a system is equal to change in kinetic energy of the system, which is given by integration of f dot ds, which is area under force displacement graph with sign. Then we have another result for kinetic energy, which can be written as half mv square or p square by 2m. Then we have force as a function of potential energy, so it's given in 3D form as F is equals to minus du by dr, or in vector form it can be written as F is minus del u by del xi cap minus del u by del yj cap minus del u by del zk cap. Then we have another expression for impulse, which is change in momentum, which is also equals to integration of f dt, which is also equals to the impact of force. Then we have another point related to force time graph. Suppose this is the force time graph, and the areas are a1, a2 and a3 with respect to sign. So impulse is integration of f dt, and it is also equals to a1 minus a2 plus a3. Then we have another point regarding gravitation potential energy of a two-point mass system. So it is u infinity minus gm1 m2 by r. Then we have another point for gravitational potential energy of earth and point mass system. So suppose the point mass is at a height of h from the surface of earth, so the potential energy comes out to be u infinity plus mgh. Now in case of vertical rod, potential energy is u naught plus mg, and we take height of the center of mass of the system. हॉरिजॉन्टल लोड के केस में अगर बात करें तो हॉरिजॉन्टल लोड में हाइट सबका सेम होगा, सो यू विल बी यू इन्फिनिटी प्लस यू ग्राउंड आप ले लीजिए प्लस एम जी एच, यहाँ से आ जाएगा. कई बार रोड हमें इंक्लाइंड दिया होता है तो उसके सेंटर ऑफ मास का हाइट आप निकाल लीजिए, तो वहाँ से आपका पोटेंशियल एनर्जी यू नॉट प्लस एम जी इंटू हाइट ऑफ सेंटर ऑफ मास आ जाएगा. नेक्स्ट वी हैव अर्थ एंड चेन सिस्टम. तो चेन सिस्टम में भी हाइट एच ले लीजिए, तो वहाँ से आप इसको निकाल सकते हैं. नेक्स्ट क्वेश्चन इज फोर्स एंड डिस्प्लेसमेंट ग्राफ आपको दिया है, तो इसका जो वर्क डन है इट इज़ इंटीग्रेशन ऑफ एफ डी एस विच इज़ ए वन माइनस ए टू प्लस ए थ्री. सो यू कैन कैलकुलेट वर्क डन बाय द ग्राफ यूजिंग दिस कॉन्सेप्ट. Then there is another concept of finding work done by the ft graph. So from ft graph you can find the impulse, which is integration f dt, which is a1 minus a2 plus a3. From impulse you can find the final velocity, and from the final velocity you can find the final kinetic energy initially, so you can find the change in kinetic energy over here, and which will be equal to the work done by the force. Then we have position vector of center of mass, it is sigma mi ri, I is equals to 1 to n upon sigma mi, I is equals to 1 to n. Then we have another result for velocity of center of mass, so this is sigma mi vi upon sigma mi. Then acceleration of center of mass sigma mi ai upon sigma mi. Next is if external force is 0, then momentum of system remains constant. This is law of conservation of linear momentum of a system. Then we have certain other formula list. For example, moment of inertia is equals to mk square. K is called the radius of gyration and m is mass of the body. For a point mass, angular momentum is mr cross v, and in pure rotational motion for a symmetrical body, angular momentum is I omega. And in case of combined motion, we have net angular momentum as I omega plus mr into vcm. Vcm is angular momentum of center of mass of the system. Then we have kinetic energy as half mv square in pure translation motion. In pure rotational, we have kinetic energy as half I omega square and net kinetic energy as sum of half m omega v square plus half I omega square. Then we have another concept of torque, which is r cross f. And from here, let's analyze this concept. Suppose there is a point P and the position vector from O to P is vector r, and this force is applied at point F. So torque of this force about origin is given by r cross f, which can be simplified to rf sine theta into n cap. So from here, if we calculate the magnitude of torque, that will be rf sine theta. So torque will be maximum when theta is 90 and it will be minimum when theta is 0 or 180 degrees. So this is analysis of torque. Now we have been asked that under what condition torque is maximum. So torque is maximum as given over here at theta is equals to 90 degree. Next is torque is minimum. So as we have already calculated, torque is minimum when theta is either 0 or 180 degree. Now there is another concept that torque is equals to fr sine theta in magnitude. So if we analyze the graph of torque versus theta, so that will be a sine graph having maximum at 90 and minimum at 0, 180. Now if we are being asked torque about an axis, so for that you just take component of torque about that axis. So suppose there is a point P on the axis, so you calculate torque about P, and suppose this is the torque and this is the angle theta dash. So you just take component of torque along the unit vectors along this axis, so that will be torque dot n into n cap. Now there is another concept of perpendicular force by area. There is another concept of stress, which is force by area, and there is a concept of strain, which is change in parameter by original parameter. Now we have modulus of elasticity as stress by strain. So this is also the Hooke's law. If we draw the graph between stress and strain for proportional limits, so the graph comes out to be a straight line. Now this is the Hooke's law, that stress is proportional to strain, and another concept which can be fetched out from here is stress is equals to E times strain. Now if we see the graphical analysis of stress versus strain for a general graph, so that is a curve like this. So we have the points OA, BC, D and E. So here A point is called the proportional limit, B point is called the elastic limit or the yield point, C is called the permanent set, D here is called the ultimate stress point, E is called the fracture point, and for ductile materials the difference between D and E is large, and for brittle it is very small. So this is as per analysis of the things, the graphs related to stress and strain for a particular curve.